This video, I'm talking you through the answers for the IGCSE paper on Tuesday, the 7th of January 2020. This is the higher, but please note this is the one HR paper, so notice the R. So this was the paper sat by the regions, so outside the UK. So it's just giving me an alternative paper to practice. Question 1. Just note that they were talking about the total amount of money that Asha and Julie shared, okay, that they had $36 between them, okay. It's not the classic question where it's $36 being shared across all three people. That $36 just refers to Asha and Julie. So Asha has 2 shares, Julie has 6 shares, so that's 8 shares in total. So that $36 represents 8 shares. Now we want to work out the amount of money that Brendan receives. He's got 3 shares. So how do we get from 8 shares to 3 shares? Well, we multiply by 3 over 8, just done 3 divided by 8. So $36 multiplied by 3 over 8 gives us $13.50. Question 2. Well, obviously we know the answer is 8 2/5, but we've got to show this. So we've got to set our workings out really carefully. So I've taken the left-hand side. First of all, I've changed these mixed numbers into improper fractions, so make sure you're okay with 3 1/5 becoming 16 over 5 and 2 5/8 becoming 21 over 8. The shortcut way, 3 5s are 15, add the 1, 16, 2 8s are 16, 16 and 5 is 21. Now you could just do top times top, bottom times bottom, so 16 times 21, 5 times 8, and simplify it down. That would be absolutely fine. But I've taken the opportunity to cancel down at this point because 16 and 8 are both divisible by 8. So I've done 16 divided by 8, so my numerator's been divided by 8. And similarly, I've done 8 divided by 8 to get the 1, so my denominator's also been divided by 8. So I'm left with 2 times 16 and 5 times 1, giving me 42 over 5. Turning this back into a mixed number, well, 5 8s are 40, leaving me 2 parts left over, so 8 2/5, as I had to show. Question 3, we've got to make A the subject. So first of all, I've taken away G from both sides, so D minus G equals 2AC. Now I've got to make A the subject, so I want to be left with A, so I want to undo this timesing by 2 and C, this timesing by 2C, so I can undo this all in one go. To undo timesing by 2C, you divide by 2C. So D minus G all over 2C is my final answer. Now factorize means putting in the brackets, and look out for the word fully. This means there's going to be more than one component coming outside the bracket. So what's the highest common factor of 9 and 12? Well, that's 3. And I've got f being common to both terms, so I can also take f outside the bracket. So then open up your bracket, and 3f times what gives you 9ef? Well, I need a 3, 3 3s are 9, and I need the e. So 3f times 3e is 9ef. Then moving on to the second term, 3f times what will give me minus 12f? Well, I need minus 4, because 3f times minus 4 is minus 12f. Now part C, expand means get rid of the brackets, and simplify means gathering up the like terms as a second step. So do your 4 clause, x times x, x times minus 5, 2 times x, 2 times minus 5. So x times x is x squared, x times minus 5 is minus 5x, 2 times x is plus 2x, and plus 2 times minus 5 is minus 10. So that's expanding, that will give you 1 mark. And secondly, the simplifying, gather up your like terms, gather up these x's in the middle. Now minus 5x plus 2x is minus 3x. Now for part D, just follow the index laws. When we multiply, we add the powers. So our numerator, 4 add 7 is 11. And then when we divide, we subtract the powers. 11 minus 5 is 6. Question 4, A part 1. Now this means B union G. So it's got to be either in B or in G or in both. So all of B, B, L, U, E. Then everything in G as well, but just obviously don't double count any letters that crop up twice. So we need the G, R, and Y added to it. So B, L, U, E, GRY. Now, this in part 2, this symbol, the upside down U, intersection, means it's got to be in this and in this. Okay, so be sure you're clear between the difference between union and intersection. So we've got to be in both W and also not in G. This G dash means not in G. So which letters are in W but not in G? Well, that's the W, H, the I, and the T. It's not the E because we're looking for ones that are not in G. So W, H, I, and T. Now, this statement by Serena is suggesting that there's nothing, this symbol here means nothing. There's nothing that is in B and in G and in W. Well, that's not true because E is in all three. So Serena's statement is not true as E is a member of B, G, and W. Question 5. So let's start off by working out the area of this garden. So this is half a circle. The area of a full circle would be pi r squared. So the area of this semicircle is half pi r squared. Now the radius is 7.2, so half times pi times 7.2 squared is 81.43 meters squared. So that's the area of the garden. Now, do we have enough grass seed? Well, we've got 12 boxes, each with enough to cover 6 meters squared. So the amount of grass seed that we've got is 12 times 6, which is 72. Well, clearly we needed 81, we've got 72, so we haven't got enough grass seed. So just put down a sentence to that effect. Question 6. Now, I think the easiest way to solve this is to factorize it. I think you were allowed to use the quadratic formula, but I think when it factorizing is the quickest route. So, to factorize it, we're going to have a pair of brackets. And because we want x squared, our first term in each bracket is going to be x. So it's all about working out these two magic numbers here. So how did we do that? Well, we're looking for two magic numbers that first of all multiply to be minus 36, but at the same time they add to be the coefficient of x. They add to be the minus 5. So set yourself up that on the side. What two numbers multiply to be minus 36, but add to be minus 5? And that's minus 9 and 4. Minus 9 times 4 is minus 36, and minus 9 add 4 is minus 5. So they are our magic numbers. So left-hand side here we factorized. Now, once we factorize this, it's easy to find our roots, to find our solutions, because nothing times whatever is nothing. So you've just got to say to yourself, first of all, what value of x would make this first bracket 0? Well, that's 9. 9 minus 9 is 0. So our first solution is 9. Because you pop 9 in here, you get 9 minus 9, which is nothing, and then nothing times whatever is nothing. Then our second solution comes from making this second bracket 0. So what value of x makes this second bracket 0? Well, that's minus 4. Now, whenever we have these percentage increase or decrease questions, I think this is quite a good idea just to write out this little table just to help you gather your thoughts. So always have the three columns, original, change, and final, and always put 100 in the original column because we're dealing with percents out of 100. Now, on this occasion, we're being told we're reducing by 15%. So our percentage change will be taking away 15%, and 100 take away 15 is 85. Now, what would we multiply 100 by to get 85? Well, 85 over 100 is 0.85. So our percentage multiplier, as we go from left to right, is timesing by 0.85. If we know the original amount and we want to work out the final amount, we would multiply by 0.85. But on this occasion, we've been given the reduced price, the final price, the sale price. So slot the 20.4 into the final price column, and we're now going right to left. So rather than multiplying by 0.85, we do the inverse. We're going to divide by 0.85. 20.4 divided by 0.85 is 24 euros. Question 8. Now, these type of questions come up all the time. And the secret is to go back to the total weights each time. So we're told that for the 5 children, the mean of the 5 children, the mean weight is 28. So what was the total weight of these 5 children? Well, it's 5 times 28, which is 140 kilograms. So it's kind of doing it the wrong way around. It's the way that we're not familiar with. If we knew the total was 140 and there are 5 children, then the mean weight, we would simply just do 140 divided by 5 to get 28. But this is the other way around. We know the mean, we know the number of children, so we can work backwards to work out the total weight of the 5 children. Similarly, the two children who get off the trampoline, their combined weight is 2 lots of their mean weight, 2 lots of 26.5. So the 2 children that got off the trampoline weigh a total of 53 kilograms. So 140 is the weight of the 5 of them, 53 is the weight of the 2 that got off. So the weight of the 3 children remaining on the trampoline is 140 take away 53, which is 87. So that's their total weight. So their mean weight is going to be the 87 total divided by the number of children, which is 3, giving us 29. Question 9. Well, let's start off by working out the volume of each block of gold. So base times height times depth. So 1.5 times 2 times 8 is 24 centimeters cubed. Okay, now you need to learn that density equals mass over volume. And on this occasion, I'm needing to work out the volume. So I'm rearranging this equation. So I'm multiplying by V, dividing by D. So volume is mass over density. Now you need to be a little bit careful here. The density is in grams per centimeters cubed. So we really need to be working in grams. So to start off with, I've converted the mass, the 5.73 kilograms, into grams. Now, how many grams in a kilogram? 1,000. So 5.73 times 1,000 is 5,730 grams. So now I'm being consistent with my units. My mass is in grams. My density is in grams per centimeters cubed, and my volumes are going to be in centimeters cubed. So I'm consistent with the units. So my mass is 5,730. My density is 19.32. So the total volume of gold that I need for the statue is 296.58. So if that's the total volume I need, and each block provides 24, I can do 296 divided by 24, say I need to use 12.357 blocks. Now, clearly, I've got to round up here. If I need 12.357 blocks, I'm going to be using 13 and have a bit left over. Just be careful you don't round down without thinking. In order to make the statue, you're going to have to buy that 13th block. Okay, so it's 13 blocks. Question 10. Now, the key bit here is that they tell us that the perimeter of the hexagon is equal to the perimeter of the triangle. So running all the way around this shape equals running all the way around this shape. So we're just going to have to construct an equation. So what's the perimeter of the hexagon? Well, we're going to have 6 lots of x minus 1. Okay, 1, 2, 3, 4, 5, 6. The total distance running around that shape is 6 lots of x minus 1. Now, with regard to the triangle, note it's an isosceles triangle. So it says it up here, and those little dashes are telling it's isosceles. So an isosceles triangle has 2 sides the same length. So this is also x plus 5. So running around this shape, I've got 2 lots of x plus 5 and 1 lot of 2x minus 3. And these 2 perimeters are equal. So really, that's the tricky bit. I've just gone and constructed an equation. So expand the brackets, 6 lots of x is 6x, 6 times minus 1 is minus 6. Expand the bracket here, 2 lots of x is 2x, 2 lots of 5 is 10, and then we're adding the 2x and taking away 3. Now simplify the right-hand side, we get 4x plus 7. Take away 2x from both sides, add 6 to both sides, we get 2x equaling 13, so x is 13 over 2, 6.5. Now, we're actually not being asked to work out x, we're being asked to work out the length of each side of the hexagon, which is x minus 1. So if x is 6.5, 13 over 2, then y is going to be 5.5, 11 over 2. We're just taking away 1. Question 11. Now, I think with these bounds questions, it's always useful just to draw number lines to help you gather your thoughts. So the weight of the cat is 4.3 to the nearest 2 sig figs. So put 4.3 in the middle of your number line and then go up one significant figure and go down one significant figure as your two goalposts. So 4.2, 4.3, 4.4. Now, which stretch of points are going to round to 4.3? Well, that's going to be all the way from 4.25 all the way up to 4.35. All these points here would round to 4.3. Now, don't worry about the fact that we know 4.35 in theory would actually round up to 4.4. What's important is we maintain this symmetry for bounds questions. So rather than put this as 4.349 recurring, please use 4.35. Maintain the symmetry. So the upper bound is 4.35, the lower bound is 4.25. Now for part C, again, start off by working out all your bounds, all right? You're going to get method marks for knowing the lower and upper bounds for both E and F. So again, draw number lines. E is 17 correct to the nearest integer. So one integer up is 18, one integer down is 16. So the stretch of points rounding to 17 is going to be 16.5 to 17.5. And for F, 9.4 to one decimal place. So one decimal place up is 9.5. One decimal place down is 9.3. So the stretch of points that round to 9.4 is from 9.35 to 9.45. Now, we're being asked to work out the upper bound for G. We want G to be as big as possible. Now, if you're taking away and you're trying to end up with a number as big as possible, you want the first number to be as big as possible and the second number to be as small as possible. Just think about it. If you're taking away two numbers and you want to end up with it being as big as possible, big take away small. So the upper bound for G is going to be the upper bound for E, take away the lower bound for F. Now the upper bound for E is 17.5 and the lower bound for F is 9.35. So take one away from the other, we get 8.15. Question 12. So the median is the middle value, and we can see we've got 60 people who have varied waiting times. There's 60 people in total. So how long did the middle person have to wait? That's the 30th person. So get out your ruler, do a horizontal line across, a vertical line down, take a reading, and that 30th person had to wait for 23 minutes. Now, the interquartile range is what is the range of values between the quarter person and the three-quarter person. So we're just focusing on those middle two quarters. So what is a quarter of 60? Well, that's 15. So take a reading on 15 and I get 17. And 3/4 of 60 is 15 times 3, 45. Take a reading on 45, I get 29. So my interquartile range, this range of times between my blue and my purple lines, is 29 take away 17, which is 12 minutes. Now for part C, we're being asked to compare that information for hospital A, 23 minutes median and 12 minutes interquartile range. And whenever you get with hospital B, which has got a median of 28, which is obviously more, and an interquartile range of 19, which is obviously more. So just make sure when you go and comment on these two facts, you contextualize it. You put it in the context of the two hospitals. So we're going to say the average waiting time, the median at hospital B is longer, because it's 28 minutes compared to 23. And then you really want to also make a comment on the interquartile range. So the bigger the interquartile range, the bigger the variability. Okay, so my second comment is going to be the variability of waiting times at hospital B is also longer, because 19 is greater than 12. Question 13. So to answer one of these recurring decimal to fractions buttons, you need to set the algebra out like this. So start off by letting x equal the recurring decimal sort of written out fullish. So with the dots on the 7 and the 2, it's the 7 and the 2 that are repeating. So 0.57, 27, 27, 27, and so on. Now, because we've got the double dot next to each other, we're going to choose to multiply both sides by 100. So obviously that's 100x, and on the right hand side, moving the numbers over 2 2 decimal places, we're going to get 57.2727 and so on. And what you'll see after the 10th column, after that the recurring decimals are lined up. So as you subtract 2 from 1, the second one from the first one, all this part of the recurring decimal is going to cancel out. So we're left with 100x take away x is 99x, and 57.2 take away 0.5 is 56.7. So the recurring element is now gone. Now, I want to make x the subject, so I could, in theory, divide by 99 now, but that's going to be messy because we're going to have a decimal tied up in a fraction. So first of all, I'm going to choose to multiply both sides by 10. So 990x equals 567, so the decimal's gone. Now I'm going to divide by 990. So that is my answer. Now I know I'm aiming for this, so I can see that I need to divide both sides, top and bottom, by 9. So x equals 63 over 110. Part B, I'm going to need to rationalise this third. And because you can see that we're ending up with no square root on the denominator. So the learning point here, you're going to choose to multiply top and bottom by the denominator, but with a change of sign. So this bit in red, I'm going to multiply top and bottom by 2 plus root y. So in the numerator, 3 times 2 is 6, and 3 times root y is 3 root y. Now in the denominator, doing the 4 clause, 2 2s are 4, 2 times root y is 2 root y, minus root y times 2 is minus 2 root y. And be careful with this fourth clause. It's a minus times a plus, so it's going to be minus. Root y times root y is root y squared, which is just y. You square something, square root it, you're back to where you started. Now, because we had this change of sign, we used the plus rather than the minus, these two middle terms in the denominator will always cancel out. And they're the ones containing the square root. So in the denominator, we're just left with 4 minus y. So final answer, 6 plus 3 root y all over 4 minus y. Question 14. So first of all, I know this angle AOC, which I've called y, is going to be twice the 38. So 2 lots of 38 is 76. And the circle theory there is the angle at the center is twice the angle at the circumference. The angle at the center, twice the angle at the circumference. Now, AO and OC are both radii. Okay, so they are equal length. So I have an isosceles triangle here. AOC is an isosceles triangle with these two base angles I've labelled x being equal. So how do I work out the size of OAC, this angle here, which they want? I'm going to do 180 take away the 76, which is then split equally between these two. So I've divided it by 2 to get 52 degrees. So given we have to give a reason for each stage of your working, mention that angles in a triangle add up to 180, but also that base angles of an isosceles triangle are equal. Question 15, we're being asked to work out the length from E to G, which I'm calling x. Now with this triangle at the moment, EFG, we know the angle, but we don't know any of the sides. So in order to work out what x is, I'm going to need to work out another length. No way to work out this length here, but obviously this length here, EF, which I'm calling y, is common to both triangles. So I can work out y looking at the triangle on the left, and once I know what y is, I can then work out what x is. So starting off looking at the triangle on the left, this right angle triangle, I'm going to use SOHCAHTOA. So from the point of view of my angle of 40 degrees, y is adjacent to me, and this is the hypotenuse, so adjacent and hypotenuse, so that's cos. So cos 40 degrees equals my adjacent y over my hypotenuse 12. How do I make y the subject? I multiply both sides by 12. Popping that into my calculator, I get 9.19 ... So I now know what y is. So looking at the triangle on the right, from the perspective of the 28 degrees, y is opposite me and x is adjacent. So I'm going to be using tan. Tan 28 equals my opposite 9.19 divided by my adjacent x, which is what I need to work out. Now, two bits of algebra here to make x the subject. First of all, I'm going to multiply both sides by x and then divide both sides by tan 28. So make sure you can see how this rearranged becomes this. So it's two steps of algebra because x is in the denominator over here, whereas over here on the left, y was in the numerator. Pop this into your calculator, you get 17.288. So to three significant figures, that's 17.3. Question 16. Now, I think this was a bit more complicated than it looked because one of the probabilities we're given is the final probability. So I think it's best to gather your thoughts here and just do a classic probability tree. So tennis is our first event, which we can either win or lose. And I'm making chess our second event, which we can either win or lose. So we're told that the probability of winning the tennis is 0.6. So obviously the probability of losing at tennis is 0.4, with these two adding up to a whole. Now I'm told the probability she will win both games is 0.42. So winning at tennis, then winning at chess is 0.2. So let's say winning at chess is X. Then when you've got to do two events, so it's winning at tennis and winning at chess, you multiply. So 0.6 times X is going to equal 0.42. So this allows us to work out what X is. Dividing both sides by 0.6, we get 0.42 over 0.6, which is 0.7. So my chances of winning at chess is 0.7, so therefore losing at chess is 0.3. And we repeat that down here. Winning at chess is 0.7, losing at chess is 0.3. Again, obviously the crocodile mouse adding up to a whole. Now, we're being asked to work out the probability she will not win either game, so the probability she loses then loses again. So losing at tennis and losing at chess, so we multiply these two probabilities. 0.4 times 0.3 is 0.12. Question 17. Now, f of 1 is simply putting the input of 1 into our f function. So popping 1 in here, we've got 1 minus 4 all being squared. Well, 1 minus 4 is minus 3. And be careful, minus 3 squared is 9. If you're going to be doing this on your calculator, make sure you protect the minus and put it in a bracket. Otherwise, your calculator will incorrectly say minus 9. Now, the range of the function is your set of y values. Now, when you square anything, the smallest you can ever get is 0, because 0 squared is 0. Anything else, be it positive or negative, when it's squared, it becomes positive. So our set of y values are from 0 upwards. So our f of x, our y values, are greater than or equal to 0. Now for part C, you've just got to remember to read these right to left. We pop 2 into the g function and see what output we get, and we take that output and make it the input into the f function. So pop 2 into the g function first of all, so into here. So that's 4 over 2 plus 3, which is 4/5, which is 0.8. Now we take that 0.8 and we pop it into the f function. So 0.8 take away 4 all squared, pop that into your calculator, you get 10.24. Question 18. Now these estimating the gradient are ever so difficult. It's really hard to go and put a ruler against a line and judge it. So what I suggest you do, just fudge it a bit. Make either the x values of the triangle or the y value of the triangle a really nice whole number. So I've made sure as I draw my straight line in, I end up exactly 6. So my x step as I look at this triangle to work out the gradient is exactly 6. And then reading off, I can see that my y value is 3.6. And remember, if your tangent is going downwards left to right, it's a negative gradient, so that's minus y step of 3.6 over x step of 6, which is minus 0.6. Now the answer, the mark scheme allows any answers between minus 0.4 to minus 0.7, a huge range of values, illustrating the fact that it's ever so hard to draw this line in accurately. Now, once you've got your answer to part A, part I, you must use that answer again in part II. Okay. Now, the equation of the tangent being a straight line, think about y equals mx plus c. The gradient we've just worked out is minus 0.6, and c is the intercept on the y-axis, which is 3.6. So y equals minus 0.6x plus 3. Now for part B, we're considering the x values from minus 4 up to 12. So this graph paper that we've been given up here. And we're being asked for the two occasions when there's exactly two solutions and not three. Now think about any horizontal lines you put here. More often than not, you're just going to be cutting the line 3 times. But at this maximum point and the minimum point, you have a repeated solution. Okay, so you're only actually getting two solutions, here and here, and here and here. So y being -1 and y being +3 are my two occasions when I only get two solutions. So the equation f of x equaling k, so it's when f of x equals -1, y equals -1, or f of x, y equaling 3. So k is equaling -1, or k is equaling 3. Question 19. Now these histogram questions are quite time consuming because you're going to have to work out the area of each of these bars, okay, because the area represents the frequency, the number of students. Now first of all, we've been told 160 students in year 11 have a height between 155 and 170. So from here 155 and here 170. So that's these two bars in their entirety, this bar and this bar. Now I'm going to choose to make my frequency density just the number of baby squares. So 5, 10, 15, 20, 25, 30 and so on. It wouldn't matter what you chose to do there as long as you're consistent with the scale you're using. So adding up my baby squares, obviously I've got a base here of 5, 155 to 160, a height of 40, 5 lots of 40 is 200. Then over here I've got a base of 10 and a height of 20 again. That gives me 200 baby squares. So 200 here and 200 here, those 400 baby squares represent the 160 students. So that's going to allow me to have the relationship between baby squares and students. Now, I've been asked to work out the total number of students in year 11. So to start off with, I'm going to have to work out the total number of baby squares. So I need to work out how many baby squares are here, here, and add it to over here. So here my base is 15, height of 18, 270 baby squares. Here I've got a base of 15, height of 15, times them together 225, and here base of 5, height of 6, that's 30. Now if I add together all these baby squares, which I've done down here, 270, 200, 200, 225 and 30, I get 925 baby squares. So 400 squares gave me 160 students. 925 squares is going to give me how many students? So I'm just looking for the proportion here. So how do I go from my blue line to my black line? What am I multiplying by? Well, I've done 925 divided by 400 on my calculator, giving me a multiple of 37 over 16. So to go from the year 11 students to total students, I've got to multiply by 37 over 16. So I take my 160 students, multiply by 37 over 16, and I get 370 year 11 students in total, having gone from the 160 who are between those heights to the total height. Okay, so in short, how many baby squares were for the heights between 155 and 170? How many in total? And just use that proportion. So the key piece of information to take away from all this narrative is the volume of the frustum, so this sort of lampshade bit here, is equal to the volume of the sphere. So let's start off with the frustum. So the frustum is created by having this bigger cone up here, the whole thing, take away this little cone at the top that's cut off. So just reading from the front of the exam paper at the formulae, the volume of the cone is a third pi r squared h. So let's consider the whole of the cone before this bit was cut off. We've got a radius of r, and we've got a height of 2h. So here we go, a third pi r squared 2h. That would be the volume of the whole cone. But I've cut off this little bit, so I'm going to subtract the volume that this little cone takes up, which has got a radius of half r, because this is similar, this is proportional, half the height, half the radius. So it's got this little bit that's cut off, it's got a radius of a half r and a height of h. So subbing in again into third pi r squared h is h, and our radius is half r being squared. And so that's on the left-hand side is the volume of the frustum, and the volume of a sphere, again, just from the formula sheet, is 4/3 pi r cubed. So they are equal to each other. Volume of frustum equaling volume of sphere. And then I've just got to process the algebra. So I've noted that they're all being divided by 3. So I've times them all by 3, each component. And I've noted they all include a pi, so I've divided by pi. That leaves me with this line here. So just make sure you're okay with that. I've times this by 3 and divided by pi. I've then just multiplied out, and just be careful here, half r all squared is a half r times a half r, which is a quarter r squared. So 2hr squared minus a quarter hr squared is just 1 3/4 hr squared. So 7/4 hr squared equaling our 4 r cubed. Now, just to undo this dividing by 4, I've decided to multiply both sides by 4. And then I've divided by r squared, leaving me here. Now I need to make r the subject, so I've just divided by 16, giving me r equaling 7h/16. Question 21. Well, there's a lot going on here, okay? We're told that the length from A to C is 6. We're told that C to E is 13. We're told that the angle BEC is 40. And we're told the area of ABC is 22. So just process all this information and get it onto your diagram. Now, we're going to have to do a lot of work here. At the end of the day, we're going to try and work out the length AB. Now, in order to do that, we're first of all going to work out the length BC. We're then going to go and work out the angle ACB, because we know the area of this triangle on the end. Once we know this angle here, we're going to know side trapped angle side. We'll finally be able to use the cosine rule to work out the length AB. So we're going to go my red workings, then my purple workings, then my black workings. So step 1, to work out the length from B to C, I can just hook out this red triangle here, 2-dimensionally, which I've done here, and I'm just using SOHCAHTOA to work out that BC is 8.356. Okay, I know the 13, I know the angle, so I can work out the length from C to B, from B to C. And then I'm just going to go and transfer that over onto this diagram here, where I'm looking at the triangle on the end. Okay, ACB. I now know that this is 6. That was given. I've just worked out that this is 8.356. Now, so I know two sides and I know the area. So I can actually work out what angle C is. So this angle ACB by using the area of a triangle rule. So for now, please follow the lettering in blue, because I've chosen to well, it already was labelled as such. The angle is C, which is actually what was given in the original diagram. So for now, follow the blue reference points for the corners, please. So following, so just substituting into half AB sin C, we know the area is 22. My A is 8.356, my B is 6, and my C is my unknown angle. So my only unknown here is angle C. So processing that through, that gives me an angle of 61.352. Now be careful, that's an acute angle. We are told that this is obtuse. So in order to go from the acute angle to the obtuse, you have to subtract it from 180. So 180 take away my 61.352 gives me 118.64. Now I'm going to move over to my purple lettering. No, my black lettering, excuse me. Now that I know this is 6, and I know that C is 118.647, and I know this side here is 8.356, I know side, trapped angle side, so I can now use the cosine rule to work out this length here, AB. And so I've changed my lettering to tie in with the formula. Do you see how my angle is now called capital A? So I'm just now following the black referencing. This is now angle capital A, making this side A and B and C. So the A's have switched really, A and C have switched. So substituting now into down here straight into the cosine rule, my only unknown now is AB. Now, I've slightly lost a little bit of detail in the rounding, I think. I've got an answer for AB squared being 153.89. I think the mark scheme says 98. So because I've rounded these, I've just lost a little degree of accuracy. But never mind, when you square root it, I still get 12.4 to one decimal place, which is the correct answer. Question 22. So we've got to think how we go from the original cosine curve, which looks like this. Okay, starting off at 0, 1, and then 90 degrees cutting the x-axis and 270 on the way back up again. How we go from the original cosine curve to this curve here. Now the a on the outside is going to be a stretch of the y values, and inside the brackets it affects the x values but opposite to what you'd expect. So let's do the easy one first. Our normal cosine curve peaks and troughs at 1 and minus 1. And we can see here we're peaking and troughing at 2.5 and minus 2.5. So there's a stretch in the y direction of 2.5. So A is 2.5. Now, not only have I stretched it, I'm also shifting it a bit in one direction. Now, so having done my 2.5 stretch, this was how the curve would now look. I might just stretch the original curve to here. And if we did nothing else, we would be cutting the x-axis at 90 degrees, but we're actually cutting the x-axis at 150. That's 60 degrees to the right we have shifted. All right, the curve has shifted 60 to the right. Now, inside the bracket does the opposite to what you would expect. So in order for it to shift 60 degrees to the right, B must be minus 60. So A is 2.5, B is minus 60. Now, following on from what I just said, part B is fairly straightforward. We've got to think about what happens to the 0.45 if we do these transformations. Now, with this first one, the change is inside the bracket, and it does the opposite to what you'd expect. So rather than doubling the x value, it's actually going to halve the x value. So halving the 4, so the coordinate would become 2, 5. Whereas in part II, this minus 7 is outside the function, outside the bracket. So we're going to be just subtracting 7 from the y value. So 4, 5 subtract 7 from the y value gives us 4 minus 2. So repeat, inside the bracket affects the x value opposite to what you'd expect. Outside the bracket, so either in front here or afterwards, that affects the y value, but as you would expect. Question 23. Well, this really breaks down into two distinct topics. The first bit is understanding how to differentiate. So in order to get an expression in terms of V, we have to differentiate the displacement formulae. Okay, now to remember how to differentiate, step 1, you multiply by the current power. Step 2, you reduce the power by 1. So our velocity expression, when we differentiate displacement, so ds dt equals, now t cubed differentiated is 3t squared, 4t squared is 8t, and minus 5t becomes minus 5, and the 7 disappears. So each time you've multiplied by the current power, reduce the power by 1. Now we're told to be using capital T and capital V, and really your work would be done now if they were asking you for an expression for V in terms of T. But it's not, it's the other way around. This is what makes it tricky. And you've got to appreciate, if we're going to make T the subject, we can only have T cropping up once. So therefore you've got to think to complete the square. So really to access almost all the marks on this question, you've got to realize you need to complete the square. So how do you complete the square? First of all, you need a single t squared. You need the squared component to be just one of them. So step 1, we're going to factorize and take out a 3, which is what I've done here. So now within the square brackets, we're going to complete the square. So what's half of 8 over 3? It's 4 over 3. So that's t plus 4 over 3 all squared. Now think about that fourth claw as you do t plus 4 over 3 times t over 4 plus 3. That unwanted fourth claw is going to be 4/3 times 4/3, which is 16 over 9. So to back that out, you need to have a minus 16 over 9. And because I know in a minute I'm just about to be adding these two fractions, I've converted minus 5 over 3 to being minus 15 over 9, just to give me this common denominator. Okay, so next step, I've just gathered these two fractions. So minus 16 over 9 minus 15 over 9 is minus 31 over 9. Next step, because I'm now going to go about trying to make t the subject, I'm going to divide by 3, which is what I've done up here. Then I've added 31 over 9 to both sides. And then again, because I really want to add these fractions together, I'm going to get a common denominator on the left-hand side. So I've multiplied top and bottom of the first fraction by 3. And then I can add these two together to give me 3v plus 31 all over 9, equaling the right-hand side. I've then square rooted, so square rooting the numerator, I get root 3v plus 31. Square rooting the 9, I get 3. And then that just leaves me to take away 4/3 from both sides. Just going to take away 4/3 from both sides to make t the subject. So I can do that by putting minus 4 in the numerator, and I've still got the 3 on the denominator. But that's basically taking 4/3 away from both both sides, from the left-hand side, I should say. So I'm left with t being the subject and t equaling this. Okay, and that's exactly in the format I wanted. So my k is 31, my m is 3.